There are other things that you can use, like Nikto or Wikto is one that has a whole lot of default lists for things like CMSs and frameworks and stuff like that. Again, go out and find the stuff. Once you've got a basic idea of the stuff that you need to do, tons of tools that you can use as long as they're within the scope. The next step to mapping out the application is to, where am I? Next step is to actually start going through the application functionally and figuring out things that the application does, especially around security, that you can come back and exploit. A lot of times the bugs that you'll find are logic flaws, implementation flaws, and they're not easily classed as cross-site scripting or SQL injection or cross-site request forgery. They can lead to those commonly classified vulnerabilities, but a vast majority of security scanners and automated tools that companies might use to protect themselves, they can only find stuff that's obviously well known, cross-site scripting, SQL injection. So where bugs tend to creep in is around poorly implemented features. So multi-step authentication, where you put your username on one page and a password on another page, and it's using the referrer header to determine that you came from the right page. Very poorly implemented, but a naive developer might think that, well, the user's never going to go in and change their referrer header. But obviously, showing you burp, you can go in and do that. You can change your referrer header. You can change your user agent string. If any of those bits of information are used as part of the functionality of the site, you can potentially exploit that. Ideal places to look, like login forms. Do they have forgotten password functionality? Can you start thinking about ways that you could exploit that? Do they have a register page, which I think this one does, but I'm not going to go to it. Actually, just turn off the proxy. You want to start mapping. So you've got a full map of all the content of the site. Now you want to start tying up the individual pages to functionality and start to build up a list of attack targets. Because the next step, once you've gathered up all the functionality, so you know that it has login functions, you know that there are particular inputs on that, you know it's got a forum or a comment section, whatever it is, go through and document all of that. Cram all the pages that are part of that into it. And if there are interesting things like a multi-stage authentication or forgot password where there's post data that you could potentially modify, maybe change the IP address or the email address or something like that, you can do all of that. Once you've done all that, the next step then is to actually start planning the attack. So you've already identified stuff that's running on the server, client-side applications like JavaScript, identified the server-side code, PHP, ASP.NET, whatever it is. You want to start trying to figure out as much. You've figured out as much as possible. You've got all this stuff documented. Now you need to go and start planning your attack. Now the planning is basically straightforward. You're going to say, I know that it's this version of JavaScript. I'm going to go to CVE and see if there are vulnerabilities for this version of JavaScript. I know that this has a user input form for logging in, and it's got 2 variables. I'm going to go in and I'm going to try and fuzz those variables. It's got a registration page. I'm going to try and create dodgy users or whatever. So you start planning this all based on the information that you've gathered as you went through. You need to get all of the data, all of the lists. So I mentioned this before. You want to start building up your portfolio of information. A good place to start, if you don't already have it, I did mention Kali's got a bunch of stuff built in. There is a GitHub repo, security list, which is a big compilation of fuzzing information that you can use for doing pen tests and bug bounty program stuff. So you can dig in here and start to find stuff about cross-site scripting, about different database attacks, things like that. So this is where it's useful to have all of the information before you get to this stage. So if you've identified from a database error page that they're running Oracle, you would come in here and start finding some of the Oracle fuzz lists. If you know that they're running PHP, you would try and find some of the PHP backend fuzz lists, things like that. Once you've done all that and you're ready to go, effectively you just start thinking about the order in which you want to do it. And that's totally personal preference. For me, I like to do all the fuzzing right away because that's generally the least likely to succeed. And you can do it relatively quickly using fuzzing tools. So fuzzing tool is basically the stuff that we were doing in Burp Suite, but automatically. So if you're pointing at a particular IP address, or sorry, a particular URL that has query string parameters, like I think there was this one here, you could do this again in Intruder, but there are specialized tools to do it. So I'm going to clear this out. So you see that there's a query string there that's looking for a year. I'm not going to go firing stuff at this because they're not part of the bug bounty program. That would be outside of my scope. But what you can do is you could say, I'm going to add that as a parameter to test. I'm going to go into my big list of SQL injection stuff. Like this. And I'm going to dump all of this stuff into Burp Suite and fire it at that URL. And in sequence, it's going to hit every single one of those. And what I'm looking for are changes in response. So if I'm getting messages, check to see if the error messages are database error messages. If I'm getting valid responses, especially some of like the blind injection stuff, you'll start to see timing differences. Pulling all this stuff into a fuzzer and aiming it at a URL is effectively what you would be doing manually, trying to put in the little tick marks and the or 1 equals 1 and stuff like that. That's basically what fuzzing is, but it's on a massive scale. And you can do that with anything that looks like a database input, anything that looks like form input, anything that's going to be reflected, using your lists, finding SQL injection lists, cross-site scripting lists, knowing the functionality of the app. Is this hitting a database? Is this being reflected as a parameter? Is it going into a stored? Yeah.
Would this be considered using like automation?
Yeah. But again, you can tweak stuff. So, for example, here, this is wfuzz is a command line tool. You can actually point this at the site and set it to do 1 request per 5 seconds. And if you do it that way, arguably it's automated. But what they're really saying when they're talking about automated, they're generally talking about stuff like Nessus and stuff like that that's going to try, a million different attacks all at once. Using tools is not necessarily doing an automated attack if you do it the right way. The main thing that they would be concerned about is that you DOS their site. So if you use the tools in an ethical way, then there's nothing to say that you're not doing it manually exactly every 5 seconds. It's the exact same notion. You could, if you wanted to, and I would not want to, but you could go through and take every single one of these strings, put it into the end of that other URL. Where was it? Did I close the page? All right. Put it into every single one of the parameters in the GET request, and you're effectively doing the same thing. So the tool is not so much the concern, it's the speed at which you're hammering the site. You don't want to open up a fire hose on them because they'll be really mad. But it's the same premise, and that's why learning to do it manually is really the best way. Sometimes you'll find a dead easy one, a little tick mark will throw up an error page from a database, and you don't really need to go further. You can say there's a vulnerability there. It's giving me information that it shouldn't be giving me at the very least. And you mark that one down, save it for later, come back and see, depending on scope, how far that gets you in. So that's basically the main idea. And all of the attack scenarios, basically apart from kind of session attacks, cross-site scripting and SQL injection and stuff like that, it's basically just a different way of doing fuzzing. And certain types of functionality are going to lend themselves to SQL injection. Certain types are going to lend themselves to cross-site scripting. But it makes no difference at all how you do it. It's the exact same process. You're firing a request over with a bit of data in it, and the server is going to respond. It's either going to like it or it's not going to like it. And if it gives you some more information, then that's potentially a vulnerability that you can start to look at exploiting. The other kind of stuff is a little bit different than fuzzing. You get into like some kind of like command injection stuff. Very rarely an application will actually be using a bit of code on the server. Maybe it's doing a DNS lookup and outputting it to a web page. That's a pretty common kind of known vulnerability scenario. But if you can find functionality that makes you think it's talking to an underlying operating system, there's a potential there to start trying to do some command injection and piping commands together. File inclusion, direct object reference, all of these are kind of more specific. It depends on how the app's been made. If it looks like it's reading in a file from its local file system, you can start messing with the path, see if you can get it to read something else. If it allows you to do uploads and then allows you to view that upload, there's a potential for a remote file inclusion there, where you could upload something malicious and get it to execute by figuring out where it's actually dumping that file. Web shells are pretty commonly done through that. So if you find a site that allows you to upload a picture, for example, and it doesn't check the content type of that picture, and you can rename it later, you could upload it as, Sean.jpg, but it's actually a PHP web shell. And once it gets uploaded, I can rename it to webshell.php, go to the page, and then suddenly I've got my own code running on their server. So that's just one type of potential vulnerability. But again, it's down to the functionality, and that's why it's so important to map out what the app does and what it doesn't do before you start trying things. If you just fire in and say, I'm going to find a file inclusion bug, if it doesn't do files, then you're not going to find one. And again, you can start attacking the server itself if there's scope to do that. Generally, on a bug bounty program, you're hitting a URL or a mobile app, so you can't hit the server itself. And then at the end of it, after you've finished everything, you found a potential vulnerability, you can go back and do a nice write-up to the bug bounty owner, to your pen test client, and say, these are all of the things I've done. These are all of the things I've found. And the more information you have, the better. You can say, I found this weird hidden content. It didn't actually let me do anything, but you might want to check that people aren't leaving database backups up or whatever. Or I found this particular injection vulnerability, and if I had the scope, it could potentially allow me to do, remote code execution, or not. Again, depending on what you're allowed to do and how far you can take that. But certainly, even just finding that as a bug and a potential issue is something that you can generally get paid for. So that's it. Burp suite aside, I talked for a good hour and a half. Do you guys have questions, concerns? Oh, all kinds. In my job, I do a lot of data protection stuff, so I find a lot of poorly implemented crypto. People storing private keys in a Java key store, and then protecting that Java key store with password of password. It's effectively the dumbest thing you could do. Or I've found bugs on GitHub where people have checked in code in their repository that had like SSH keys in it and stuff like that. GitHub is actually clocked on to a lot of that, and they run scanners in the background to fix that. But yeah, that one is a pretty bad one. At another bank I worked for, they had this internal chat application, which is like all highly regulated and audited and logged and stuff like that. And I found out a way to basically log in as somebody else, So I was like sending my buddy messages from our boss telling him he's fired and stuff. Again, you gotta be careful because, you know, if you found something like that and you weren't in the security team, they would probably get pretty pissed off about it. A really funny one, actually. So JP Morgan's well-known, well, not well-known, probably nobody outside of JP Morgan knows it, actually. But internally, there's a lot of people that work there. Internally, we're really big on pushing AppSec to our developers. And there's loads of training from Cigital and all these certificates and all this kind of like bullshit, rah-rah stuff that we try and get developers to be defensive programmers and stuff. And to be honest, a lot of it's crap. It's like videos from Cigital. It's like, you know, sit down and watch an hour-long video, and then you get a certificate at the end that says, wow, and have organization can write out encoding so that you don't get hit with cross-site scripting bugs in your applications. And at the end, they ask you to enter your email or your name to get printed on the certificate, which had a cross-site scripting vulnerability in it. And a buddy of mine was like, I think this might be wrong. I was like, yeah, that's not good. That's pretty good. So yeah, video without cross-site scripting in the end had a cross-site scripting vulnerability. Yeah, totally screwed themselves. But yeah, I mean, some of the stuff like the